afternoon, everyone. Welcome to yet another lecture of the web-based decision support systems course for the decision makers and the academicians, practitioners, some broader stuff. So, we have been discussing on different aspects of DSS system. So, today if you look into it quickly as a quick recap, we looked into DSS and we have 4 subpart of DSS. One is DBMS, database management system, then MBMS, model based management system, then KBMS, knowledge based management system, and UIMS, user interface management system. And we have taken a brief look into all of them, and now we are looking in depth into database management system. So, we studied what is a database, database, we looked into that what it is. We also looked into what is called as a entity relationship diagram. Okay. We saw what is a schema. Okay. So, how to translate what are the 3 layer architecture. Okay. And then we studied what is the concept of primary key and foreign key. Okay. And then we also studied what we call as how to translate from an ER diagram to a tables. So, ER diagram to tables and some brief introduction of SQL. We have gone through this many aspects of it. So, now all these aspects are being completed from our side. Now, today we are going to look into what we call as a new thing called normalization, and also we will try to continue to learn something about MySQL and some commands of MySQL. And finally, we will try to wrap this whole lecture out with what we call as a introduction to big data, and the remaining aspects of the big data will be taken over by other instructor Dr. Amandeep Singh Oberoi. And once this is done, I will move towards user interface management system or model based management system, depending upon how much time and other things are we left out. Remember, all these are supposed to give you the brief introduction to the course and make you familiarize with the ideas, and the applied side, the putting it into practice, learning it to how to do it on a server side will all be done as part of the advanced course, which will be subsequent to this one. Okay. So, today we are going to learn the topic database normalization, and it is a very important topic, especially when it comes to DSS, because the DSS uses data plus models plus decision maker, and that translates to business decisions. Okay. So, the DSS supports this all the 3, and using which we create what we call as a business decision, which will have an impact, a financial impact on the organization. So, let us see what is normalization, the concept of normalization. Okay. So, there are many definitions available, okay, and again from a DSS standpoint is what we are going to talk about, what is the normalization and the concept of normalization. So, the simplest definition for this, it is kind of a definition that we suppose a logical design method. Okay. It is a logical design method that minimizes data redundancy and reduces database design flaws. Okay. So, it is a logical design method, fundamentally it is a logical design method. The aim is to minimize, okay. It has to minimize 2 things. What is it? Number 1 is minimize the data redundancy, and also number 2 is to reduce the database design flaws. The second aspect is how to reduce the database design flaws. Okay. So, what does it entails to? Because the question is what does it entails with, or what does it, what are the major steps associated with it. Okay. So, the first part is consists of applying various the quote unquote normal forms, okay, normal forms to the database design. Okay. We will see what is the normal forms, but DESIGN. Okay. So, the first thing is you have multiple normal forms that are available, or normal forms, quote unquote normal forms, and we take these normal forms and apply it to the database design in a sequence, right. And why do we apply normal forms? Normal forms. Okay. The reason is the normal forms breaks down or break down large tables. Okay. What tables? Large database tables. Okay. Large tables into smaller subsets. Okay. So, as I said earlier, it is a logical design method, okay, and there is two aims. Number one is to minimize data redundancy, that is the first goal, and number two, to reduce the database design flaws. Okay. Those are the two goals of the normalization. So, what does it consist of, or how do you achieve this? What do you do is you keep on applying, okay, you consistently apply various normal forms. We will talk through what are different normal form, first normal form, second normal form, there are so many normal forms. We take these normal forms and we apply to the database design. Okay. And why do we do this? Why do we make these things? Because these normal forms help us in breaking down large tables, large database tables into smaller subsets, okay, so that it can be managed better. Okay. The aim is to manage these database tables better, because once you have a smaller tables, okay, then it is easy to manage and better. So, that you can also reduce redundancy and reduce the design flaws. Okay. All right. So, without further delay, we go into what we call as the first normal form, usually represented as 1NF. Okay. First normal form. So, what comprises or constitutes, what constitutes of first normal form? Okay. What consists of first normal form? So, the first one, the part 1, the initial thing is each attribute, okay, must be atomic. Okay. So, atomic is a word, interesting word that we need to understand. What does it means? Okay. So, it means two things. Okay. No repeating columns within a row of the table. Okay. So, you cannot have a column repeating. Okay. So, no repeating columns. The first criteria is for every row you cannot repeat the column. Okay. So, same column thing cannot be repeated. Part 2, the second part is no multi valued columns in a table. Okay. So, you cannot have repeating columns and you cannot have multi valued columns. Okay. So, this is what it amounts to be. It is a first normal form, each attribute must be atomic. Atomic means you cannot, there cannot be any repeating columns and there cannot be no multi valued columns. So, the goal, what is the goal of the 1NF? Okay. 1NF or first normal form 1NF aims to simplify attributes, okay, entity attributes. So, attributes you can think about as columns, okay, simplify attributes. So, why do you need to simplify attributes? Why? Okay. Why simplification? Why simplification is important, or why do we need simplification? Okay. This why is an important question. The answer is make queries. What queries? Database queries, okay, easier, okay, or queries become easier. Okay. Our aim is to make the queries or queries become easier. So, queries become faster, quicker, and you can actually query the database without too much of confusion. So, that is what is the need of first normal form. Again, as I said earlier, what comprises or constitutes of the first normal form or fundamental question, and the rule is that each attribute must be atomic. Atomic means no repeating columns, no multi-valued columns. If these two conditions satisfy, we can call it as atomic, and the aim is at simplifying. And why? Because to make the queries easy. So, let us talk about one enough example. Okay. Let us see a demonstration how this we can take care of it, right. So, let us take a table here. There is an employee table, okay. We call it as an unnormalized table, and we have been discussing this in the previous. So, if I do a schema of this, the employee number. So, the schema will be something like this. Okay. If I do the schema, it will be I am challenged by that employee number, then there is a name, then there is a department number, then department name and skills. Okay. This is a schema, and the employee number with an underlining. So, that means this is the primary key, PK. I call it as PK, not the movie PK. PK stands for primary key. So, then you can see that there is an employee 1 named Lady Ada, belong to department 201, and the department name is R&D, and the skills are C, Perl and Java. Okay. So, 3 skills. Employee number 2 Charles Babbage from IT has Linux and Mac as the skills, and the employee 3 Boy Scout from department R&D, again same department, DB2 Oracle and Java. Okay. So, now what happens is the rule says no repeating columns. Okay. So, there are no columns that are repeating. So, one and enough rules are no repeating columns, okay, no multi-valued columns. Okay. These are our rules. Okay. So, now when you look into this, the first part is okay, we do not have any repeating columns, but the second part is we have a multi-valued. So, this is our multi-valued column. Okay. So, this means this table, employee table, is currently not in first normal form. So, how do we make this into first normal form? The way to make this into first normal form is remove this multi-valued column. So, then the resulting table in the one enough will come to be something like this. Okay. Employee number, name, department, skill. So, you will see employee number 1, employee number 1, employee number 1, Lady Ada, all these details are repeated where the skills are different. Okay. So, by normalizing, what happens is there is only this column got simplified. Okay. Simplified, there is no more multi-valued attributes. We can search how many people in this whole thing knows Java. So, we can basically say Boy Scout also knows and Lady Ada also knows Java. So, this problem becomes much more easy, but you can see that this much of information is repeated, and so is this also, and so is with Charles Babbage also, but I am just showing this. Okay. Okay, is repeated, and Charles Babbage also is repeated. Okay. So much of redundancy has now added. Okay. So, in the row wise you added redundancy, but in that process you eliminated the multi-valued columns. Okay. But as per the definition of one enough. So, this is a 3 row table. Okay. Now, this has become a 8 row table. The 8 row table is now in one enough. Okay. Or 8 rows are created. So, that this multi-valued column the last column skills column got to what we call as a first normal form. Okay. Hopefully, this makes sense. Now, let us talk about the following one. So, because remember what is normalization? We sequentially apply a set of normal forms to make the table, the database design better. So, second normal form. Okay. So, the second normal form is the criteria or goal of the second normal form is to each attribute must be functionally dependent on the primary key. Okay. The each attribute must be, this is a mandatory condition, and it should be functionally dependent on the primary key. Okay. So, now the question is, what is functional dependency or what is functional dependence? Okay. What is it? Okay. So, the functional dependence means, in by simplest terms, the property of one or more attributes. It is a property of certain attributes, one or more attributes, that uniquely determines the value of other attributes, Okay. So, what we are saying here is, when you say the functional dependency is a property of one or more attributes, certain attributes in a table, has a capability to uniquely determine the value of other attributes. So, if you know one attribute, then you can determine the rest of it. Okay. Then how is 2NF applied? How do you apply this? Okay. The application part of 2NF is pretty simple. Any non-dependent attributes, what means any functionally non-dependent attributes in a table, are moved, you remove them, are moved into a smaller table, or a subset table. Smaller table is also known as a subset table. So, any non-dependent attribute in a table is moved, you move them into a smaller table or a subset table. Okay. What does 2NF accomplish? What can you accomplish by the 2NF? So, the first thing is 2NF improves data integrity. Okay. So, what is the data integrity? So, the data integrity is a big question. What is it? That is, it is a preventing update, insert and delete anomalies. Okay. So, the main aim is to improve data integrity. And what is data integrity? Data integrity is to prevent, update, insert and delete anomalies. And what these anomalies? Anomalies we will see with examples, quickly once we go through. So, the rule is, you first apply 1NF. The first step is apply 1NF, second step is to apply 2NF, and after that you do 3NF, 4NF, etc., like that, right. So, we now know what is the second normal form. So, now let us take an example of the functional dependence. Let us see what functional dependence is. So, let us take the table that was in the 1NF, the previous table, the same table that we saw before, where the skills was a multi-valued attribute, this was a multi-valued, Okay. So, we eliminated multi valued attribute. Okay. So, this multi valued attribute was eliminated and we got the table in the first normal form. So, in this case, okay, we can say or we can conclude few things. The name, okay, department number, okay, and department name, okay, attributes, okay, are functionally dependent on employee number. Okay. So, in another way to say it is that employee number, okay, which is the key attribute, determines the name, department number and department name of an employee. Okay. So, if you look into this, that is the functional dependence. So, if you know the employee number, you can figure out the name of the employee and which department that person is working for and the number of the department. Okay. So, then the other part is you should also see that then what about the last column? Okay. Skills, okay, is not functionally dependent, is not functionally dependent, okay, on employee number. Why is it not functionally dependent on employee number? Because or since, because it is not unique to each employee, okay, or employee number. So, knowing Java is not unique to Boy Scout, it is other people can also know Java. So, you cannot say that the employee number 3 uniquely determines or functionally determines the individual skills of the person. So, then what happens is the skills aspect of it is not really something that can be determined by employee number. So, one other way to denote this is typically what certain type people do is this: they create a schema diagram, they say employee number, okay, then there is a name, okay, then department number, okay, and department name. This is another approach people do, and skills, okay, and employee number you draw something like this. Okay. So, that means the employee number functionally determine all these 3 attributes and not the skills attribute. Okay. So, that is something that is outside the functional dependency of this table. Okay. So, now how do we get it into this one? How do we convert into 2NF? So, example of 2NF. See the example of it. So, the table that is in the 1NF form, the employee number name with the skills and everything, which was reduced from the unnormalized form to 1NF. What we do is we first create a table, because remember the process is, what is the process? Process is to break into smaller subset tables, okay, so that the functional dependency can be maintained. So, first we break it into a thing where these aspects, the 2NF table, the employee number uniquely determines the name, department number and department name of the person. And so, this is a new table, employee table, this is a second normal form table, and we create a second table, okay, 2NF table called skills. Okay. So, we just keep record of what are the skills each individual employee has. Okay. So, if a person acquires a new skill, so the person 2 Charles Babbage acquires a new skill of accounting, or let us say tally software. So, then we add tally right here exactly. Okay. So, that can be added into this and we do not need to change anything in this. So, you can see now that all that data that is being redundant. Okay. So, this entire, okay, these were redundant information. okay, that when came here got reduced. Okay. Now, we can see that non redundant. Okay. By the time you implemented the functional dependency, this breaking it into two tables, all these retyping the name of the person, department number, R&D, everything is gone, and the only time where you can actually see repeating happens is just this one. Okay. So, now we can see that the resultant database, okay, has become much more efficient in comparison with that of the original database, where all these data, these 8 columns, all the data has been redundantly kept on stored. Okay. So, now let us look at what he call as, I mentioned a term before, what he call as data integrity, right. So, this is the data integrity, preventing update, insert and delete anomalies. So, let us talk about what is data integrity. So, by illustrative examples. Okay. So, we are going to look into this by each individual example. Okay. So, the first one we are going to see is what we call as insert anomaly. Okay. I can't spell. So, please double check my spelling. Okay. So, what is an insert anomaly is, that is in the simplest things, it is called as adding null values. Okay. So, here is an example for this. Okay. So, inserting a new department, okay, inserting a new department does not require the primary key of employee number to be added. Okay. So, one example is this. So, I am creating a new department called 203 and it is called as marketing. Okay. So, if I add something called 203 marketing right here, okay, then this value will be null and can be null, and this could also be null, right. So, this is called as an insert anomaly, because this information, by just adding a new department into this, I will have to put null values for the remaining thing, because having an employee information is not really mandatory as part of this. Now, that is the first one. Now, let us talk about it as update anomaly. Okay. Update anomaly. Okay. So, what is an update anomaly? Okay. So, that is multiple updates for a single change, okay, thereby causing performance degradation. Okay. Degradation. Okay. How is this? Let us take an example for this. Okay. So, that I can example. Okay. Changing IT department name to information systems department. Assume that we change the IT department name, IT to information systems. Somebody decided to change the name of the department. So, what do you do? Okay. You end up going here, you change this and you have to change this. If I change the department R&D, okay, to, I will say, innovative design or something like that. So, then 1, 2, 3, 4, 5, 6 rows I have to go there and type and make the changes, right. So, when you make a single change, like for example, in this case the single change we can talk about as a name change. Okay. So, then it will result in, you have to change it in many places wherever this department name shows up, and the all data has to be removed and then the new data has to be put in. And when you have so many rows, now only we have 8 rows, assume there are 8,000 rows, then you go through and change wherever rows this department name is appearing twice. Okay. So, that becomes the update anomaly. Now, let us talk about here is the delete anomaly. Okay. This is also another anomaly. Okay. And the simplest way to say about this is deleting wanted or necessary information. Okay. Now, for example, let us take an example out of this. Okay. Deleting the IT department. Okay. If I delete the IT department, will result in removal of employee. Who will be removed out of this? If I remove the IT department, Charles Babbage will be removed from here. Okay. Employee Charles Babbage. Okay. Charles Babbage from the database. Okay. So, let us say the top person decides that ID department is useless, we need to remove this department. So, they deleted it, and in this kind of a table where you have not taken care of stuff like this and you deleted the IT department, then along with the deletion of IT department, Charles Babbage's information also, the employee who is necessary, who was the only one with the Linux and the Mac experience in the organization, also gets deleted out. Okay. So, these three things, what we call as data integrity as part of this, is basically driven by the insert anomaly in number 1, update anomaly and delete anomaly. Okay. And the aim of doing 2NF is to prevent these anomalies. So, now we move to the third normal form, 3NF. Okay. So, our first step is apply 1NF, second step is apply 2NF, and now the third step is apply 3NF, is something that we need to learn at this part of it. Okay. So, third normal form, okay, the goal or aim, what do we gain to achieve by doing a third normal form? Remove, the goal is to remove transitive dependencies. Okay. To second normal form was to make sure the functional dependency, here you are trying to remove transitive dependencies. Okay. So, question is, what is transitive dependence? Okay. So, what is this new word transitive dependence means? Okay. The simplest way to answer to this question is two separate entities. Okay. Two separate entities exist within one table. Okay. So, there is one database table, okay, one you can think about as one database table, okay, one single database table in which two separate entities, okay, or two separate items that are physical existence exist within the same table. Okay. So, how do we address transitive dependence? Okay. How do we handle this? The way is, any transitive dependencies, okay, are moved into, we move them into what you call as a smaller or a subset of tables. Okay. So, we reduce them into a subset table. Okay. Same way as we do the functional dependency, here also we move into a subset table, right. So, what this results in, okay, or why, what does the third normal form do? Okay. So, 3NF further improves, it improves more, it improves data integrity. Okay. The aim is again it further improves, okay, it improves data integrity more, okay, which means again prevents update insert and delete anomalies. Okay. So, in this table we have seen that, okay, if you look into this, we can see that this department number and department name, department is also another entity and employee is another entity, they are coexisting in one table. Okay. Though functionally it is okay, but transitive dependency, which means two separate entities existing in one table, does not really help in this regard. So, then how do we solve that problem? Okay. So, as we said earlier, we will take the table that is in the 2NF, which is the employee name. So, we have a one entity which is the employee, okay, which is an employee number to it, okay, and then there is a name of the employee as part of this, and then there is a department entity, okay, that is a department number, okay, and department name. Okay. So, both these are two separate entities, but they coexist in one table. Okay. So, that is the one what we call as transitive dependency. So, how do we solve that problem or how do we address this problem? So, the way to think about it is department number and department name are functionally dependent on employee number. Okay. They are functionally dependent because employee tells you what department the person is belonging, right. However, okay, department can be considered, can consider as a separate entity. Okay. So, as I shown you here, okay, they are two separate entities. So, you can consider them as two separate entities. Okay. So, then how do we tackle this problem? So, the simplest thing to do it is the example. Let us work this example out. So, the employee 2NF table, employee number name and with the two separate entities existing in it. So, to move it into the 3NF, okay. So, the first part is we break the employee number, the employee name and the department number, only the department number into one table, and we have the department, a newly created table. This is the subset table that is created, okay, and this is the existing table moved into 3NF. Okay. So, the employee table got reduced. So, the department name got removed, but the department table, the 3NF, the new subset table that is created has department number with the department name as part of it. Okay. Now, when you look into this, the table that we have, this new 3NF table that we have created, earlier also we have splitted in 2NF, we had created a skills table, okay. That was another subset. So, as we go through, we keep on applying normal forms, we break tables into smaller things to make sure that the table becomes the, you can easily manage the database and update, delete and insert anomalies can be managed. Okay. So, then comes the other normal forms. So, we have gone to first, second and third normal forms. Okay. Now, there is three more other normal forms. Okay. So, the first one we are going to talk about is Boy's code, okay, normal form. It is also known as BCNF. Okay. Usually, we will talk about the order of application. Okay. So, what is this aims to? Okay. The main aim is it strengthens third normal form. It is a subset, some people consider it as a subset of 3NF, but it strengthens the 3NF by requiring the keys in the functional dependency in the functional dependencies, okay, to be super keys. Okay. That means it is a column or columns, more than one columns, a column or columns that uniquely identify a row. So, the Boy's code normal form literally means that if you have a table like this, okay, and you have, let us say for example, P k 1 and P k 2, the two primary keys, okay, composite primary keys, and we have attribute 1, attribute 2, attribute 3, attribute 4 and attribute 5. Then whether either this 1 or 2, they should all uniquely identify together identify the remaining 5 columns. Okay. So, the entire row is uniquely identified by this. This is a stricter form of third normal form. Then what we call as the fourth normal form. Okay. People call it as 4NF. Okay. So, the fourth normal form, and what is the main aim of this is the eliminate trivial multi-valued dependencies. Okay. These things we will discuss more down in the remaining lectures, because these are outside the scope of this introductory class. Then comes the fifth normal form, okay. It is 5NF, okay, and the aim of this is eliminate dependencies not determined by keys. Okay. So, whether it is a primary keys or a primary key or a super key Okay. If there are any dependencies that cannot be determined by the keys, then eliminate those dependencies. So, the order of application for us in this regard, okay, how do we apply this? The order of application in this is, okay, 1NF first, followed by second normal form, then third normal form, okay, then Boy's code normal form, then fourth normal form, then fifth normal form. This is the order of application, but okay, the designer can choose to stop at any level based on the requirement. There is no rule that says you have to go all the way to the fifth normal form. You are free to stop at second normal form, you can stop at BCNF, you can stop at fourth normal form. It is all depending upon the type of the database that you have, the application of the database, and how the DSS is supposed to utilize the database. Okay. So, many of the time I have seen people just applying first normal form and calling it good, but that need not be the good idea, because many a times you may also end up getting redundancies in the row. So, it may be better to go to second normal form, third normal form. I usually in complicated databases I take it to third or Boy's code normal form, but 4NF and 5NF usually when you require really good speed, extremely good retrieval and write speeds, then you need to look into the higher normal forms. Okay. So, with this we complete this portion of the lecture, especially of looking into normal forms, where we have now seen how do we take the database design, the tables that you design, and you break them into smaller ones, so that your queries and other kind of things are efficient and quick to process. So, we are not seen in details what are the major queries, which we will cover in the next class, what the major queries are, and then after that we will take a quick look into how these queries pertaining to MySQL or MariaDB, and after that we will look into what is big data, and then we will call it good after that, and that would probably cover the basic requirements of database DBMS and the database management system and that component of the DSS. Thank you very much.